This is my particle simulator. I'm just going to do a brief demonstration, show you how it works. I hope you like it. So first we're going to say how many particles, how many balls we want. It can be up to 5,000. I'm going to make it 2,500. We then say how large we want our particles. Be as large as 50 pixels. This is their radius. Or we be small. I think we should have it small because we have so many. So let's say 3. This is our directions. And I'll explain them later as I go through the demonstration. Okay, so let's begin. So this is the beginning of the program. 2,500 particles have just been rendered, all rendered from the same place. This is our, it's generated randomly where they originate from, and each one has a random velocity. It simulates a square because almost every velocity is taken into account right now. So if we want to make a gas chamber, what we can do is drop points and draw lines. It can be any geometry we want. For now, let's just do a square. I'm going to press play and we'll see what happens. So as you can see, they're confined into our little gas chamber right now. As you saw, I was able to draw lines very easily. Just drop the point, drag, click again, and I have a line. Every single particle reacts the same way. It bounces depending on the angle at its impact. You can draw as many lines as you want. If we want to delete a line, you just hover over any endpoint and just press delete. We can also add balls onto the screen. So we can create our own little place right here. Press play. Have a right there. So let's restart. And next thing I'm going to show you is how we can include collisions in our simulator. Now in a normal gas chamber there isn't much interaction between particles, so this isn't completely accurate, but we are going to do it with not many balls. Let's just say we have 40, and let's make them a much larger size so they're more likely to interact. Press play. So now they're all bouncing on the screen. They're not interacting right now. You see the collisions over here is off, but if I press shift, they start bouncing off of each other. It's not a perfect simulation, but it's fairly accurate. It gives you a pretty good idea of how the particles would interact. Once again, you can still draw lines, and the balls will still bounce off of them. The last thing I want to show you is, oh, I got an email notification. We're going to, once again, let's say we have 3,000 particles, and size 3 pixels again. And let's create our little chamber like we did before. Again, this could be any geometry. I mean, any geometry you want. Just doing a square right now, just to make it easy. That's right. So once again, all the particles are contained. But if we want to get some interesting behavior, we can delete one of these walls and see what happens. So I'm going to play, and I'm going to delete this. As you see, particles will start slowly dispersing, and given enough time, if we let this run, we would see that this entire screen would be filled up equally with particles, just by random probability. That might take a lot longer because a lot of balls are still confined over here, but as you can already see, it's already filling up quite a bit. So that's an interesting result, just probability. I think it's kind of cool. So this is the end of my demonstration. I hope you liked it. Thanks for watching.